for those that might not know, Raspberry Pi is a small credit card sized, low cost single board computer. They come in multiple versions of these boards. So they've been around for about 9 years, but there's multiple flavors of these boards to pick from. And there's lots of good resources online to set them up and get started using them, and guides for parents and teachers. There's clubs and events around this. And the Pi includes all your normal ports that you'd expect, right? USBs, Ethernet, video, audio. But there's a 40-pin general purpose I/O header at the top that's kind of the primary one that, that shines with the Pi here, that header lets you interact with the real world. So as I was looking to build something with the Pi, kind of for a demoable example, I had a brother in California reach out to me to help him build a 2-axis solar tracker. So Pi project found. So here's just a simple view of kind of the extremes for sun path, from June to December. And then kind of a more detailed view of that. So you can see, for June, the elevation rise and the spectrum of how much more coverage there is in the east-west movement, right? And then you got everything in between those dates, right? So what I was trying to solve is, how could I use just date and time? So without the hardware to do identification where the sun is at, but use just date and time, how could I get sun position data without being internet connected? So PVLib is a simple answer for that. There's an open source project that you just import the library and make one call to get solar position data, passing in a time and a lat long, and you get back the sun position data for that time slot. So I set out building a kind of a demo-sized mini 2-axis tracker. So what you see here is there's a kind of at the end of my workbench here, there's 2 6-inch linear actuators. One controls the elevation angle and the other controls the azimuth east-west position. Each actuator contains a potentiometer that I can feed back into the ADD converter in the system that I'm building, that allows me to understand where the actuator's at. So with calibration, I know where to point to the sun then. So every minute the app compares the PVLib provided solar data, and it compares that to the angles that the system is at. And if that error exceeds a threshold, the appropriate actuator is activated to move the sun back into alignment again, or move the system into alignment with the sun. So here's a picture of kind of the main boards involved here. The bottom board is the Raspberry Pi 3B+. Next up in that list there is a dual channel motor controller board used to independently control each actuator. Then next up is a 4-channel 16-bit ADD converter used to translate those pot position values in the actuators. And I've also got a wind speed sensor hooked up to this too. So they refer to these add-on boards as hats, or hardware attached on top. So here's a picture of kind of the finished controller with the terminal blocks for the field wiring, so the power coming in, each actuator, and a spot for the anemometer to plug in. Here's kind of the last few pieces before I shipped it off to my brother. So I added a 7-inch touchscreen display, and then there's an anemometer in the foreground here too, spinning. So the anemometer, that, like I mentioned, it's a safety feature. It allows the system to tip the solar system into a horizontal position if there's any, high winds. I ended up using this is all written in Python, a tkinter forms GUI library. So you can create kind of a WinForms application looking thing. So it's got time, solar angles, the amount of air, wind speed, that kind of thing. And there he's got it hooked up. So he was building the system at the same time I was kind of putting the hardware electronics together. So that's the finished system. Currently pointing facing west. The sun is just about to set there. So this is out near San Francisco. The big box underneath the panels there is all the batteries in this thing. But the solar panels there's 10 of them. It's 12 foot by 16 foot. Allows it to rotate 180 degrees and then tip, kind of between 20 degrees all the way up to almost horizontal. So there's, once the sun sets below the horizon, the application just reverts the system back to facing east in preparation for the next day's sun.